Kablow. We're giving you the rate of change of the radius, which is 3 centimeters per second, and asking you for surface area and volumes rates of change. We are going to do those separately as separate problems. If I know dr dt, which I do, let's write that out. Dr dt is 3. And I want ds dt, which is the rate of change of surface area. This is centimeters per second, too. We need an equation that links radius to surface area. Well, that's not that crazy, right? The surface area is just 4 pi r squared. So when we derive that, we get ds dt, which is what we're looking for, is equal to 8 pi r dr dt. And we happen to know r and dr dt. Dr dt is 3, and r is 10. So this is 8 pi times 10 times 3, and you do get 240 pi. And look, let's talk about why it's centimeters squared too. We haven't talked about units too much, but if you look at the ds dt formula, we have the radius, which is measured in centimeters, right? And we have the change in radius, which is measured in centimeters per second, or minute per second. So we have centimeters times centimeters per second, which is centimeters squared per second. Cool? That's why the units are what they are here. All right, that's the first part. That finds ds dt, which we should write. But then I also asked you to find dv dt, which we have to use a totally new formula for that, which is volume. So I'll do it up here. Let's change colors. That'll be fun. Let's do it in blue. Okay. The volume equation, which we all have memorized at this point, true? Yeah, Sophia. Is 4/3 pi r cubed. And when we derive that, we just get 4 pi r squared dr dt. Now, do you notice anything weird about the derivative of volume? What equation is that in there? It's surface area. Have we talked about this?
No.
Okay. If you think about a sphere growing, let's say we have a sphere. There it is. Boom. As it grows, its rate of change, you can imagine, as it's growing, what you're really doing is putting like a super thin shell on it as it grows, right? And the shell has to have the surface area. So as it grows, it's growing at the surface area. That's why the rate of change of volume is surface area. Okay? The same thing happens with circles. The rate of change of the area of a circle is the circumference, because as it grows, it's growing by its circumference, spreading out. Okay? If we want dv dt, now we're just plugging everything. So here, AJ, this is easy. You're just a calculus superstar. R is 10, right? So r squared is 100, and dr dt is 3. So what's this? 1200?
Yeah.
So dv dt is 1200 pi, but that's in cubic centimeters per second.